Hi, welcome to section 7. This is going to be covering monopolistic competition. This is going to be the first section, obviously, that we have online. So again, I just want to go over basically what the protocol is, at least the idea that I have for the protocol going forward. We can sort of, based on your feedback, based on the feedback form that I'm going to send out, obviously this is open to revision, but basically the idea is that I'm going to post section lectures online in advance ahead of section. And so the idea will be that you'll view them ahead of time, sort of scribble down, like I had a question here at sort of, this minute marker. And then during our sort of regularly scheduled section time, we'll have a Zoom meeting, and then there you can ask me sort of questions that you have on any of the section material, or really on any material in general. I think basically what section time will be closer to is sort of now will be office hours. And so I think this format could really end up working well, insofar as it's a bit restricting to have it online, but obviously we have to do that. I think it will work well because it allows section videos can be a little bit longer depending on whether or not the section is longer. They can be a little bit shorter, and so that way basically section videos will be able to cover things really in depth, and then we'll be able to free up a little bit more time for questions and for clarification. So I'm personally excited to see how this format works. I think it could make the most out of obviously an unfortunate situation. And so I'm looking forward to hearing your feedback. Okay, so let's jump right in. So just to give you an outline of where we're going to go in section 7, we're going to review the monopolistic competition model. We're going to review 2 of the curves, which are going to define the equilibrium in the model, go through a numerical exercise in this model as well. And then, but before getting there, what we're going to do is we're just going to review a little bit of a sort of theory of monopoly, and that hopefully will give you a little bit of insight into the monopolistic competition model. Okay. So what we're going to do is we're going to start off by reviewing a standard monopoly problem. This is entirely optional. If you've just taken a course on monopoly, this all seems straightforward. Feel free to skip this part. But just to review, monopoly is going to be a setting in which there's only one firm in the market, and it's going to be supplying a good for which there's no close substitute. So if a monopoly is the only firm in the market, then it's not taking a price that's given out there. And so the monopolists we're going to think are not going to be price takers. They're going to potentially set a price higher than their marginal cost. And so what's the result? The result is going to be that if consumers out there have a given downward sloping demand, then the marginal revenue that a monopolist receives from selling an additional unit of good is not fixed, even if their marginal cost is. Okay. And so let's think about the sort of profit maximization problem of a firm with marginal cost C. And let's think about what their profit maximization problem is going to look like if we're in perfect competition. If we're in perfect competition, then a consumer is not going to purchase a good from a firm if it's going to charge a price higher than its marginal cost. And so the reason is because there's another firm out there in the world which is going to also produce the same good, but it's going to charge a different price, P dash, which is still greater than the marginal cost, such that price that the other firm is charging is less than the price of the first firm, and so on. Therefore, if we look at our consumers, the consumer's demand is basically going to be given by their demand is going to be 0 for whatever that good is if the price is anything greater than the marginal cost, and their demand will be positive if the price is equal to exactly equal to the marginal cost. And so we have a bunch of firms competing, and so each of them in competition is going to bid down the price to exactly equal to the marginal cost, because if any of them was selling at a higher price, a price above the marginal cost, they'd all just compete with each other to lower a price because they and gain market share. Okay, so for a firm to operate with positive sales, it has to set a price equal to C. In other words, it's a price taker. And so formally speaking, the firm's profit maximization problem is going to be given by maximizing pi of Q or profits, where profits are going to be given by P times Q minus C times Q. And so then the optimal price for this problem is obtained by taking the first order condition of that problem with respect to Q and setting that equal to 0. And so just to see how this is done, let's suppose that the profit of my firm is equal to pi of Q. It's equal to P times Q minus C times Q. Okay, so if I want to take the first order condition of this problem, then what I'm going to do is I'm going to take the derivative of pi with respect to Q. What's that going to give me? It's going to give me P minus C. And then for this to be a first order condition, I need to set this equal to 0. So what is this going to imply? It's going to imply that for a firm to maximize profit, it's just going to need to set price exactly equal to the marginal cost. So that's just showing with first order conditions that setting a price equal to the marginal cost is going to maximize a firm's profits. And so that's just showing that what's on the slides. Okay. So now let's move on and consider the case of a monopolist. And so now here, the good produced by the firm is not produced by any other firm. And so we're not going to think that there's going to be other firms which are going to come in and bid down the price. So of course, now that there's one firm here, consumers may choose to purchase fewer units than if the price were lower. So in other words, we're going to think that the consumer has a sort of classic standard downward sloping demand curve, Q of P. And so that's going to look like exactly as you usually draw a demand and income 101 setting. Okay, so then if the demand curve is Q of P, then if we just write everything we invert that function, and I'll show you how to do that later, then the inverse demand curve is just going to be denoted by P of Q, or price as a function of quantity. And we're going to assume that the derivative of the inverse demand curve with respect to Q is going to be negative. Okay, so then the firm's profit maximization problem looks very similar here. It's just going to, what's going to be different now is that price is now going to be a function of quantity. Okay, and likewise, the FOC is just the sort of optimal price that a monopolist sets is just going to be obtained by taking the FOC with respect to quantity and setting that equal to 0. So it's written out on the slides, but I'll do that. I'll do that on the board. So let's see. So now we have everything is the same as before, but what changes is now that we now have price as a function of quantity. Okay, and so now let's take this first order condition of the profit function with respect to Q. So what we'll get is partial profits with respect to Q. That will give us, so I'm going to apply the product rule here. So I'm going to take the derivative of the first term times the second plus the first term times the derivative of the second. So that's that. And now we're just left with this. Okay. And then we need to set this equal to 0. And so that's going to give us our profit maximizing condition. So what we should end up with is P prime of Q times Q plus P of Q is equal to C. Okay. And for some reason, my slides have gone back. Okay, so that's exactly what this is saying. So if we just rewrite what I have written on the board such that we just have the price on the left-hand side and everything else on the right-hand side, then recalling that P prime of Q is always negative, then note that the price that a monopolist is going to charge here is going to be above C. Okay, So it's going to be higher than what's going to be, the price is going to be higher than what it was in perfect competition. Okay, so let's denote a couple of features of this. So we can note that the revenue of the firm is just going to be what's given here. So this is revenue. And then our second part is going to be the costs of the firm. Okay. So with those definitions, then if we take the derivatives of revenue and costs, note that this here is just going to be marginal revenue. And C is just going to be equal to the marginal cost. So essentially, the condition that we found that's going to choose Q such that the monopolist is maximizing profits is basically going to be the familiar condition that we have to set marginal revenue equal to marginal cost. So what our FOC is saying is that the firm is going to, at optimum, choose Q such that marginal revenue is equal to marginal cost for that optimal Q produced. And then what is it going to sell at? Well, if we know that it sells at Q star, if we know that it produces Q star, then it will sell at an optimum price P. P is a function of Q star. Okay, so that's just quickly reviewing how the monopolist chooses optimal quantities and prices. We'll see this a little bit more with an example. So just graphically now, we have a standard sort of downward sloping demand for the good that the monopolist is going to produce. That's a D. We have a sort of fixed marginal cost. So there's so we're not thinking that there's so we're just going to think that marginal costs are just going to be perfectly flat. And then here, since everything's linear, then marginal revenue is just half of industry demand. And so our monopolist is going to pick a quantity such that marginal revenue equals marginal cost, and then they'll go back to what industry demand looks like, and they'll set a price according to what the market is willing to bear, given that they're producing at an optimum value of Q. So now let's do this out with an example. So suppose that we know that the market demand for a good is given by QP equal to 10 minus 2P. Then what we want to figure out is we want to figure out what the optimal price and profit is going to be in an equilibrium for a monopolist with marginal cost C equals 2 and F equals 1. Okay, so the first step that we want to do, and this is just going back to sort of what we did before, is now here, notice that we have P as a function of Q in my solutions. And so if we want to use this rule, we're going to need to figure out the inverse demand curve. Okay, so let's start out with what we know. We know that market demand is QP equals to 10 minus 2P. And we want to write, this is our demand curve, or this is our demand function. And what we now want to write is we want to write the inverse demand function. So we want to write P as a function of Q. And so the way that I'm going to do this is I'm just going to say, this implies that Q is equal to 10 minus 2P. I'm just going to move the 2P over to this side and subtract the Q over on the other side. I'll get this. And then I'm just going to divide by 2. And so what I'll be left with is that P of Q is equal to 5 minus Q over 2. Okay? So now this is our inverse demand function. Okay, so that's good. So now let's go back to that we know that the rule that's going to set an optimal value of Q is setting marginal revenue equal to marginal costs. Okay, So what we'll have here is we need to now figure out what marginal revenue is. So we can just use this formula and note that P prime of Q here is just going to be equal to 1/2. So what does that imply? That implies that now if we have this condition, that marginal revenue is now equal to 5 minus Q over 2 minus Q over 2 equal to C. So these terms combine, and what we get is we get that 5 minus Q has to be equal to C, and thus that the optimal amount of Q my monopolist will produce is just going to be given by C. Sorry, it's going to be given by 5 minus C. Okay, and now C here is 2, and so this is equal to just 3. So I figured out that the optimal quantity produced by my monopolist is going to be 3. Okay, now that I have this, that's great. Now what I want to do is I want to figure out what the optimal price is going to be. So I'm going to plug this Q back into here, the inverse demand function, to figure out the optimal price. Okay, and so what's my optimal price going to be? Well, it's just going to be P of Q star. So I'm just going to plug in there, and what I'll get is I'll get 5 minus Q star over 2, which is then equal to 5 minus 3 over 2, which notice this is 10 over 2, so then this is equal to 7 over 2. Okay, and so that's how we solve for price once we know optimal quantity. Okay, so now let's go to the slides. Okay, so let's see. So figured out the inverse demand curve. That's what we did up on the board. So we figured out what marginal revenue was. It's equal to the 5 minus Q. Then, given our cost function, we know that the marginal cost is equal to 2. That's what we did. Oops. Oh, I'm all the way back. Wait. Sorry about this. Okay, so we figured out marginal revenue. We figured out marginal costs. Okay, and then once we figured out marginal revenue and marginal costs, what we then did is we set them equal to each other. We figured out that Q is equal to 3. At an optimal Q of equal to 3, we set a price equal to market demand, which gives us that the price is equal to 3.5 or 7 over 2. And then if we want to calculate profits, we just go back to our equation for profits, which is equal to, it's basically just revenue minus costs. We can plug in for everything. And again, we're just plugging in for values of optimal Q here. And it turns out that optimal profits are also going to be 7 over 2 or 3.5. Okay, so that was a review of how a monopolist sets prices and quantities. We're going to see some of those dynamics play out in the monopolistic competition model. So just to review what the monopolistic competition model aims to do, we often see that trade is going to occur between countries with very similar technologies and factor endowments. And so the models that we've looked at across the Heckscher-Lean specific factor models and the Ricardian models of trade all don't explain this phenomenon. In these models, when countries are identical, we won't have trade. And so we sort of want to, the thinking is we need to have a model that explains why similar countries are also going to trade. And so there's going to be two key assumptions of the monopolistic competition model, which is going to aim to explain some of these features. So the first is going to be that a firm's average cost of production is going to fall as it produces more. So when we come back to what its cost function is going to be, you're going to see that. And then the second is going to be the firms are going to have some market power, like a monopoly, but we're also going to introduce an additional consideration, which is why we call it monopolistic competition, that firms are also going to earn zero profits. And so today, in today's section, we're just going to focus on the case of one country under autarky. So a little bit more about the key ingredients of the monopolistic competition model. We're going to see that each firm is going to produce a differentiated product, say almonds versus cashews, and that sort of differentiated product is going to protect that firm's market power within its industry. Firms are going to each sort of set their own pricing decisions while taking sort of market decisions or their rivals' prices as given. So we're basically going to assume we're going to solve for the price that one monopolistic competitor is going to set, assuming that all of its rivals' prices are given. And so I'll come back to that, but that's sort of important to sort of keep in the back of your mind. We're going to have free entry and exit of firms. So if there's profits to be had, firms will enter, like they would in perfect competition. Likewise, if firms can't recoup their fixed costs, then they're going to exit. And we're going to have decreasing average costs as production increases. So as you produce more units, that decreases your average cost. And then consumers in this model are also going to enjoy more variety of goods. So I'll come to that. So let's jump into what the setup of our standard monopolistic competition model is. So we're going to have many firms indexed by I. So it can be, we can have 1, 2, or sort of n number of firms. Each firm I is going to produce a differentiated good. And since each firm only produces one differentiated good, we'll refer interchangeably to firms and varieties as I. It doesn't really matter. A product I is produced by a firm I, so we can really refer to a firm or a product as I. So it doesn't matter. You can think of it as the cost function of one variety or the cost function of a firm. They're the same. Okay, and then the cost function of all firms is going to be given by C of Q, which is just equal to C times Q plus F. So where CI is some marginal cost and FI is the fixed cost. We're going to let S denote the total demand or market size, and N, we're going to let that be the number of firms operating in the market. And now we're going to suppose demand for good I is given by this expression here, where what we're calling B, B is sort of, is the sensitivity of demand with respect to price. And then P bar is going to be the average price across all goods. And so what I mean by when we're thinking about P bar being the average price across all goods, when we're going through all of the steps to figure out what a firm's optimal quantity and price it's going to set, we're going to assume that P bar, this average price across all goods, is going to be sort of unchanged by what that firm's decision is. We'll see later that we'll go through the math, we'll see what the firm is going to set a price at, and we'll see that it will set the price, if firms are homogeneous, it will set the price exactly equal to the average price. So we'll go back, and then once we assume that all firms are the same, we'll see that the price that the firm is going to set is exactly equal to the average market price. But for now, we'll just assume that that average price P bar is, when we're thinking about what the firm is going to set, it's going to be more or less unaffected by what one of individual firm's decision is. But I'll come back to that. So, and then what we're going to assume is that the market size S is basically just a a sort of a demand, what the sort of total demand is, and then we have the sort of quality that market demand must be equal to sort of market supply. So we'll think that, for instance, if the example is that we have almonds and cashews, there's a certain market size for instance for groundnuts, and then sort of different firms will supply different varieties of for instance groundnuts. So there will be cashews, peanuts, almonds, etc. Those will be Q2, Q1, Q2, and Qn, and then those are going to add up to the total market size. So we're adding together sort of the quantities produced of different varieties. Okay. So now let's go ahead and derive two key equations of this model, starting with the PP curve. Okay, and so recall that the demand for each firm's output is going to be given by Qi of Pi. So we're just copying this expression that we had on the first slide here. And so if we just multiply everything out by that S, and by the B in parentheses, we'll get this expression. And what we want to do here is we want to go and we want to do what we did with our monopolist, and we want to start off with their demand and then solve for the inverse demand. And so let's do this out on the board. So what we have is, let's start off with, we have Qi is equal to S over N plus BSP minus BSPI, okay? And so we want to have price as a function of quantity rather than the other way around. So what I'm going to do is I'm going to add BSPI to both sides, and then I'm going to subtract Qi from both sides. So what this will give me S over M plus BSP bar minus Qi is equal to BSPI. Okay, and then I'm just going to divide by BS on both sides. So what that will give me PI as a function of Qi, which is now equal to S over B, S over N plus BSP minus Qi. Okay, these S's are going to cancel, but we'll be left with a S there. And then these B's will cancel here, but not here or here. Okay, so what we'll be left with is 1 over NB plus P bar minus Qi over SD. Okay. Okay, so that is now our inverse demand function. Okay, and so then under monopolistic competition, each firm is going to produce a differentiated good, and so it's going to act as a monopolist for that particular good. And so like as we just did in monopoly, the firm is going to set marginal revenue equal to marginal cost. And so let's recall that in general, we have marginal revenue is equal to P of Q plus P prime of Q times Q. Okay, and so what we want to figure out is what marginal revenue is going to be for this particular monopolist. Okay, and so what I'm going to just do is I'm going to stick this inverse command here. So what this will be is it'll give me P bar plus 1 over NB minus QI SB. We don't know what P prime is, but if this is PI of QI, then P prime I of QI, well, this is the only term with Q in it, so it's just going to be equal to 1 minus SB. So then this second term here is now 1 minus SB times Q, so it's minus Q over SB. Okay. And what does that become? That's now just equal to P bar plus 1 over NB minus 2 QI over SB. Okay, so that's how we figure out what marginal revenue is here. And you can sort of see that what we're going to do is we're now going to figure out what marginal cost is. Okay, so I'm going to leave marginal revenue up on the board. I'm going to erase everything else. And then what we're going to do is we're going to set marginal revenue. Oops. Oh, jeez. We're going to set marginal revenue equal to marginal cost. Okay. So let's do that. So I know that my firm's cost function is given by this. So in order to get marginal cost, I'm just going to take the derivative of my cost function with respect to QI. So marginal cost of I is just equal to the derivative of CI with respect to QI. And so that's just going to be equal to CI. Okay. Then we know from before that the rule that's going to tell my monopolist what the optimal quantity they're going to produce to maximize profits is just going to be setting MR equal to MC. Okay, so now let's do that. So so monopolistic. So my monopolistic competitor chooses Q star such that MR is equal to MC. And so let's set this expression. Let's bring up this one. So this is marginal revenue. So we get P bar plus 1 over NB minus 2 QI over SB. And that just will be equal to CI. So now all I'm going to do is I'm just going to solve for QI by itself. What that will give me is it will give me, on the left-hand side, we'll actually have 2 QI over SB equal to P bar plus NB minus CI. And then all I'm going to do is I'm just going to multiply on both sides by SB over 2 to get that my optimal QI will be equal to SB over 2 times the stuff that I had on the right-hand side initially. Okay. So that's the optimal. Q that my monopolist is going to produce. What's my optimal price that my monopolist is going to produce? Well, recall that the price was started to be, at first was given by, so recall that I had PI equal to P bar plus 1 over Bn minus 1 over Bs Qi. And so if I want to now solve for what my optimal price is, then my optimal price is going to just be given by plugging in this Qi into this. So what will I get? So what I'll get is that I'll have that this is equal to, this is going to be equal to P bar plus Bn. And then I'm plugging in Qi here. Notice that these BS's are going to cancel. And so I'll be left with minus P over 2 minus NB over 2. Okay. And then plus Ci over 2. And so what is this going to reduce down to? It's going to reduce down to if Pi is equal to Pi over 2, or sorry, P bar over 2 minus, oh sorry, plus 2 over NB, or sorry, 1 over 2 NB, and then plus Ci over 2. Okay, so that's that one. Okay, so that's basically what I did. And note there's a typo on these slides. It should be plus Bn. Okay. So next, so that's basically how the monopolist is going to set price. And for now, what I'm going to do is I'm just going to leave the monopolist price like that. And then what we'll do is we'll come back to it once we've made an assumption that these firms are homogeneous or not. Okay. So next, what we're going to do is we're going to derive what's called the CC curve. And so what the CC curve is going to be is it's just another way of referring to the average cost of a firm of producing Q units. And so the average cost is going to be given by basically the total cost divided by the quantity produced. So you can sort of see that it's going to be the average. And so the average cost is just going to be here, if we divide the sort of total cost by Q, what we'll get is that the average cost is equal to the marginal cost plus the fixed cost divided by the quantity that we produce. And so for later, it'll be helpful to note that you can notice that the average cost is going to be decreasing in the quantity produced. And the reason is that the marginal cost is going to be the same. That's going to be fixed. But if we have these large fixed costs that we need to cover, the more units that we can spread that fixed cost across, then the more our average cost is going to come down. And so because we now have these fixed costs in our costs, that's going to drive what's going to lead to a decrease in our average costs if we end up having more scale to produce more. Okay, so I'll come back to this equation as well. So now everything we've done so far, all of this has been just assuming that firms are not homogeneous. And now what we're going to do is we're going to assume that firms are homogeneous. And so it's helpful to specify what that means. So what does that mean? Well, first it means they have the same cost functions. And so everything that was in the cost function that was a function of I can now just take out. Everything is now just going to be, there's going to be one marginal cost for all firms. There's going to be one fixed cost for all firms. So all of their cost functions are just going to be the same. If they're homogeneous, then they're also going to charge the same prices. And that way, PI is just going to be equal to the average price for all firms. And then finally, they're going to produce the same quantities. And so, you know, if QI is equal to some Q for all firms, then we can just go back to that equilibrium condition where market demand has to be equal to market supply, and we can note that that the quantity that each firm is going to produce, since they all produce the same quantities, is just going to be whatever market demand is divided by the number of firms. Or in other words, Q is going to be equal to S over N. Okay. And so now what we can do is we can start by coming back to the PP curve. And so recall that our monopolist is going to charge a price PI. And so now what we can do is we can use that homogeneity assumption to figure out, to sort of simplify the price that they're going to charge. Okay? And so you see sort of the outline of where I'm going with this, but let's do it out on the board. Okay? So what I have is now I've solved for my optimal price down here, and I'm just going to rewrite it here. Okay, so I have that PI of QI star is equal to P over 2 plus 1 over 2 MB plus CI over 2. Okay, and so you know, if PI is equal to P bar for all I, then what is this going to imply? This is going to imply that I have PI is equal to PI over 2 plus the rest of these terms. And so if I subtract this this PI over 2 on the other side, what I'll get is PI over 2 is equal to all of these terms on the right-hand side from before. And then I'm just going to multiply it by 2 on both sides. And what I'll get is that PI is going to be equal to 1 over MB plus CI. Okay. We're just rewriting that slightly. I said what this expression is telling me is that the price that my firm I is going to charge is going to be the marginal cost that it has, where, of course, the marginal cost is now no longer a function of I, so I can remove all of these i's here that I had initially, plus 1 over NB. Okay, and that's, of course, that's also going to be equal to the average price of all firms as well, too. And so what you can note here is that the price is going to be exactly equal to the marginal cost as n gets really large. So as n gets really large, we're gonna think that we're gonna be close to competition, and so as the number of firms really grows to infinity, then the price starts to approach PI is just equal to the marginal cost. And so this is why we call it. This is one of the reasons why we call it monopolistic competition, because as the number of firms grows, we get closer and closer to the competition. So so that's one thing. If we rewrite this as PI minus C, sometimes this is called the markup, or the price the price that the firm charges greater than its marginal cost, and so the markup again is just equal to 1 over NB, and that as well, that term as well goes down as the number of firms increases. So this is just saying what I did on the board. Okay. So again, notice that the markup goes down as we increase the number of firms, meaning that we're getting closer to perfect competition. Okay. The markup of the firm is also going to decrease as the parameter B increases. And so what B is representing is the price sensitivity of consumers to this product. And so if a firm's sales are more sensitive to prices, then you'd think that a firm also might charge a lower markup to sell more output. So for more price sensitive consumers, the firm can't mark a price up as high on above what its marginal cost is. Okay, so now let's come back to the CC curve. Now, with all firms homogeneous, we just, in our cost function, we can get rid of all of the i's. And so we just have that our cost function for each firm is the same for all firms, and it's just C times Q plus F. But we've also said that each firm is going to produce the same quantity because they're homogeneous, and so Qi is going to be equal to S over N for any firm I. And so what we can do is the average cost is going to be the same as before. It's going to be C plus F over Q. But now we can just plug in for Q, noting that each firm is going to produce just what the market output is divided by the number of firms. And so now we get that the average cost for a given firm is equal to its marginal cost times the number of plus the number of firms times its fixed cost over the market size. And note that as n increases, the average cost is going to increase. Why is that? It's because as we increase the number of firms, the output that each firm is going to produce decreases. Note that if Q is equal to S over N, you can sort of see that that as n increases, Q is going to decrease, and so that's going to increase average costs. That means you have you're producing less of a quantity, and you can't spread out your fixed cost among as many units as you could before. Okay, so we've already obtained. So now let's think about what's going to define our equilibrium here. So we've already obtained the solution for what price each firm is going to sell to maximize profits. That came from the rule where we said how much, let's set marginal revenue equal to marginal cost for this monopolistic competitor, and then figure out what optimal quantity is going to produce. So we've already obtained that. But now to solve for the number of firms and what the price, what the equilibrium price is going to be, we need a second condition. And so that second condition is going to be that firms are going to earn 0 profits. Okay, and so let's talk about what it means for a firm to earn 0 profits. So recall that profits here are just going to be equal to what I'm going to call pi of Q, which is equal to P as a function of Q times Qi plus, minus the cost that it has of producing all of that output. Okay, so this is this is big C here. So this is representing the total cost, which is inclusive of fixed costs. Okay, then what I'm going to do is I'm going to say that our second condition now, because this is a monopolistic competition model, the element of competition that we see in just sort of the perfect competition is that firms are never going to earn profits; they earn 0 profits, and so that's going to be the element of why we call this the monopolistic competition model. We have firms that have market power, but each of them is going to earn 0 profits, and so that this is going to be the competition part of the model. So we're going to say our second condition is that each firm earns 0 profits. And so let's see what this implies. So if this is equal to 0, then what does that imply? That implies that this above is equal to 0. And so what do we have here? We have that P of Q times Q. This needs to be equal to C of Q. Okay, so that's just setting this equal to 0. And then what I'm going to do is I'm going to divide on both sides by Qi. So what I'll get is I'll get that the price needs to be equal to CQi over Qi. Okay, but you can notice that this left-hand side is just the price, but the right-hand side, well, if I take the number, the total cost I have, and I divide it by the number of units I'm producing, then what this is the average cost of producing Qi number of units. So the 0 profits condition, this condition, is identical to the condition that we have P equal to AC. In this model, we're going to call price sort of what this term is here. We're going to call this, as I said, we're going to call this the PP curve. And we're going to call AC, we're going to call this the CC curve. So this zero profits condition is the same as, is also the same as, or sort of it's equivalent to saying that we have the PP curve is equal to the CC curve. Okay? But don't be confused. The PP curve and the CC curve are just the same as price and then average cost. They're just called the PP and CC curves. Okay. So okay, and so now what we want to do is we want to go through and we want to set price equal to average cost, and then use that condition to figure out what that'll give us. And so if price is equal to C plus 1 over Bn, and average cost is equal to C plus NF over S, that's what we found previously, then note that those marginal costs are going to cancel out. And so when we want to figure out what the equilibrium number of firms that we have in our market is, it doesn't depend at all on marginal costs. And so we can go through and do the algebra here. And what we'll find is that the equilibrium number of firms is just going to be equal to n star equal to the square root of S over BF. And so I can do that math out. So again, what we'll have is we want to have that P is equal to AC, and so P here is equal to C plus 1 over MB. Average costs here are going to be C plus NF over S. Okay. As I said before, these C's cancel. We can just get rid of them by subtracting them from each side. And so then what I'll do is I have NB equal to NF over S. What I'm going to do is I'm going to multiply by N on both sides. So what will that give me? I'll get that N squared will be equal to SF over B. And therefore, I'll have that N is equal to square root S over B. Okay. Then, how do I figure out what prices are going to be here in equilibrium? Well, if I have this N star, then I just go back to my equation for price and plug in N star here. And so what that's going to give me is it's going to give me that P star is just equal to C plus 1 over N star P star. And so just substituting in for everything, what I'll get is I'll get that I'll get that C is equal to C is equal to C is equal to square root S F. Oh yeah, I see. Sorry, that should be that should be. Sorry, I just had a bit of a brain fart there. Yep. So we get. Sorry. So yeah, that's right. So then we get F over SB. So that's going to be the price that we derive from. Okay. So what's going to be the equilibrium here? We can just draw what the CC curve and the PP curve look like in terms of as a function of N and price. And the CC curve is going to be upward sloping. That is, average costs are going to be increasing as we increase the number of firms. That's because they produce less, each of them. And the PP curve is going to be downward sloping as a function of N. That's going to be that as N increases, competition gets more intense, and that's going to drive down prices. Okay, so now what we're going to move on to is we're going to move on to a numerical exercise. And so what we're going to suppose is we're going to suppose that we're going to consider the industry for industrial lasers in the US. And so you're going to think industrial lasers, you know, in order to make them, it's going to require you make some large fixed investments, buying the machines to make lasers. I presume those are pretty expensive. And so upfront investment, we're going to assume must be equal to F of $10 million. Variable costs are going to be constant, and they're going to be equal to C equal to 50,000. And then the market price is going to be given by P bar as equal to C plus one over Bn, where N is the number of firms in the market, and B is equal to S over the 200. So P bar is equal to 50,000 plus 200 over N. And then we're going to think that the autarky market size in the US for industrial lasers is going to be S equal to 4.05 million. Okay. And so given the setup with increasing returns, why do we consider a market with monopolistic competition? Why not perfect competition? So the answer we might think is that if in perfect competition, each firm is just going to charge its marginal cost. So it's going to charge a price that's exactly equal to its marginal cost. And if it does that, it's covering exactly what the sort of marginal cost is to make that, but it's not covering the fact that it needs to spend $10 million up front, regardless of how much it's going to sell to buy the machines used to make lasers. And so we might think that we need to have monopolistic competition because we need to have firms be able to charge a price such that they're covering their marginal, such that they're covering their initial fixed cost. Okay, so they need to have market power. They need to be charging a price greater than marginal cost. Otherwise, they're never going to be able to recover their fixed cost, and profits would be negative. Two, why would the market price depend negatively on the number of firms in the market? Well, you can sort of see here that that P bar is going to decrease in N, and the way you can think about this is that there's going to be some competition. So as we have more firms, they're sort of going to increase competition. And so that's going to make the demand for each firm more elastic, or sort of more responsive to prices. And so this is going to reduce the markup and lead to lower prices. Question 3 is asking that we sketch the industry equilibrium autarky for the US with the market price on the vertical axis and the number of the firms on the horizontal axis. We can do that. Basically, the intersection of the CC curve and the PB curve are going to tell us the sort of equilibrium number of firms and the equilibrium price. Of course, we haven't showed you how to get those numbers, and so question 4 is going to ask, what's the equilibrium price of lasers and equilibrium number of firms? You already see from question 3 that it's 9 and 50,000, 22.22, but let's see how we do that. Okay, so where we're going to start is we're going to start based on what our assumptions tell us about the costs. So we know that the fixed cost is 10 million, variable cost is 50,000. So our cost function is going to be equal to 50,000 times Q plus 10 million. Dividing our cost function through by Q, we get that our average cost of 50,000 plus 10 million over Q. But since we assume that we have homogeneous firms, Q, the amount that each firm is going to produce is just going to be the same across all firms. So it's going to be equal to S over N, where S is equal to 4.05 million. And so plugging that in, we get that the average cost is equal to 50,000 plus n times 10 over 4.05, where notice that those 10 millions have just canceled out. Since B is 1 over 200, then we have that the average price is going to be equal to C minus 1 over Bn, which is going to be 50,000 minus 200 over n. Okay, and so all we're going to do here is to solve for the equilibrium price of lasers and the equilibrium number of firms. We're just going to set, again, P equal to AC. And so here, we come back to this. And what we have is we have that this is now equal to 50,000 plus 200 over n plus 50,000 plus 10 over 4.05 times n. Okay. Again, we can just subtract by 50,000 each side to have these cancel out. So what we'll be left with is we'll be left with 200 over n equals to 10 over 4.5 n. Okay. I'm just going to multiply by n on each side, and to get that n squared is equal to 200 times 4.05 all over 10. Okay. I can cancel out a 0 here with the 10, so I'll just be left with this. And then to get n by itself, I'll just square both sides, so n will be equal to 20 times 4.05. You can note that that's equal to 81, which of course is 9 squared, and so the square root of 81 is equal to 9. So in equilibrium, we should have 9 firms. Okay. Then, knowing that you know that that the number of firms in equilibrium is 9, you just come back to price, and that's equal to C plus n over B, where this is 50,000 and B is 200. Okay, so now we're just going to plug in 9 here, and what we'll get is that our equilibrium price will be 50,000 plus 200 over 9, which is approximately this number. Okay. So that's how we'd solve in a case like this for what the equilibrium price and number of firms are. Okay, and so this is just listing out all of that math. Okay. So now we're going to suppose that there's going to be a shock and the market size is going to increase from S equal to 4.05 million to S equals 7.2 million. What's going to happen to the PP curve and the CC curve? And what's also going to happen to the price and number of firms of the equilibrium? So notice that the PP curve doesn't change. There's nothing in this setup here that I'm going too far back, but there's nothing in our setup of where we've defined the inverse demand for a monopolistic competitor that depends on the market demand, S. And so the PP curve doesn't really change. The CC curve is now going to become flatter because we now have a larger market size, and so average cost is not going to increase as fast with the number of firms in the industry. So now average costs are now 50,000 plus n times 10 over 7.2. So now what we can do, if we just want to go back through and calculate the new number of firms, all we need to do is we just come back here and we change S equals 4.05 to, we change it to 7.2. Okay. I'm just changing the value of S here. So if I multiply through on both sides, what I'll be left with is that n squared is going to be equal to 20 times 7.2. Okay, but 20 times 7.2 excuse me, is equal to 144. And so the square root of 144 is just equal to 12. And so that's how we now solve for the number of firms. We're just plugging in for a new value of S before into our average cost. Okay, and then here, when we figure out what our new equilibrium price should be, again, we're just going to plug in for 12 here rather than N. So that's going to give us our new price. Okay, and so our new price is equal to 50,000 and 16.6. Okay, and so that's depicted as follows. So the CC curve, as I said, it's going to become flatter, so it's going to intersect the PP curve at a lower point, leading to a larger number of firms in equilibrium and a lower price. Question 6 is asking, suppose that the government is going to impose a tax on the firm's inputs, laser resistors, increasing its variable cost. What's going to happen in equilibrium? Are there going to be more or less firms? So intuitively, we're going to think that both the curves are going to shift up. Why? A tax on the firm's inputs is going to increase C. And so note that in both the PP curve and the CC curve, we have C. But the thing that you want to note is that looking at this intersection of these two conditions, we have that these variable costs C cancel out here. So nothing should change about how now we've calculated N. So the number of firms, you want to think, well, C's, these cancel. We didn't care about them in the intersection of P equal to AC. So the number of firms will stay the same, but what will change is going to be the price, because now we've just increased the price by, say, from 50,000. The variable cost, we've increased it from 50,000 to now we've increased it to 50,000 plus whatever the tax is on the variable cost. So we've increased price. We haven't changed the number of firms. What have we done to each curve? We've just basically shifted them up. Okay, so let's go through on the slides. So both curves are going to shift up. And so if average cost is going to increase, as variable cost is going to increase, because this is the cost of just producing an extra unit of output, this is going to shift the CC curve to the left on the graph, so when we come to that. And then on the other hand, because of the increase in marginal cost, the firm, you might think, has to increase marginal revenue by increasing its price and reducing its output, since the firm is going to lose money if it continues producing the same amount quantity, given that the cost of producing some range of quantity is going to be higher than the revenue the firm's obtaining. And so this is going to shift the PP curve up. Again, these two effects are going to cancel out, and the number of firms isn't going to change. So the price, obviously, as I said, is also going to increase. Each firm is going to reduce output, but it's going to charge a higher price. Okay, so it's going to be depicted as follows. And so note that the two shifts in both the new PP curve and the CC curve are going to result in the same number of firms in equilibrium with just a higher price. Okay, so that was section 7. As I said, tomorrow I'll have a Zoom section to answer any questions you might have about this. And so I'll see everyone. Thanks so much.